Uh, Today I'm going to talk about a relation between data science and Spark, mostly focusing on data science, how data science works nowadays. So first of all, a definition about data science. And data science is an interdisciplinary field to extract knowledge or insight from various types of data, from unstructured, structured, small, and big data. Which is actually the continuation of data analysis using data mining approach, using machine learning, using artificial intelligence, and so on. But today we have a new definition for data science. Actually, today we tell data scientist is someone who knows math and statistics, machine learning, artificial intelligence. He knows about programming and database, for sure. Programming mostly R, Python, and Scala. And new things that has been added to data scientist techniques is domain knowledge and soft skills. It means that if you want to be a data scientist, you have to have some knowledge about the field that you are going to work on. For example, if you are going to be a data scientist in finance system or banking system, you definitely should have some knowledge about the banking system. If you are going to work in a healthcare system, you should have some domain knowledge in healthcare system. And it's why it has made this field of study or this career a bit challenging. And other than that, you should have communication and also visualization skills to just tell the story about the data, just to take out the result from your data and just convey it to your customer or your manager and so on. So the question that sometimes comes to your mind is that why we should learn data science, first of all. And I found actually there are a few reasons. First of all, data science can be used for social good, right? Last year, UN has released 17 goals, sustainable goals. And we think that data science can help UN goals as well. Just to give you an example, there is a company, I think his name is Give Direct. This company is supposed to collect some monies from international charities. It's a non-profit company, and direct this money to poorest people in Africa, right? And the way that they used to do is just sending some representatives to different villages in Africa because the census there are not reliable or doesn't exist. And the money that this company paid to these representatives to send them, for example, to Kenya is much more than what this company is supposed to help to poorest people. So some experts from IBM has with another company, I think his name is Enigma company, came together and they used satellite images to just find the poorest regions in Africa. And the way that they did was just to look at different houses in the village. There are some houses that their roof is thatched roof, and some of them are metal roofs. And they found that the areas of village that have most metal roofs, they are more rich, and the roofs that are thatched are usually the poorest people and are actually a good target for helping them. So you can see that they could use some kind of big data, data science, and image processing all together to recognize these people and direct the money to these areas. Also, we can have usage of data science in industry, right? Last week, I was giving a talk in Mumbai. One of attendants asked me that, say, already there are many algorithms, many techniques in data science, like recommender system, like, I don't know, classification, other things that big companies are using this, right? For example, Amazon is using recommender system. So what's the point that we learn recommender system or other things? And the things that these companies needs are usually data engineering. It's people who extract data from data sets, from different data sources, and integrate this data and just pass to the data scientists. And if already there is a recommender system, so what's the point for data science? So I wanted to, actually I answered this question with one example. Around, I don't know, 7 or 8 years ago, I was, a company, an insurance company approached me and told me that we have a big data set and we have a data set of automobile accidents, right? And we had a good revenue in the last 2 or 3 years ago, and still our revenue is not bad, but there is some kind of rumors that we have some frauds and people can play with our system. So, Said, can you help us with this data set? And I accepted and started analyzing their data, right? But the problem was, finding fraud in this kind of data set wasn't that easy. Because usually fraud detection in normal way is you find some kind of patterns of fraud. For example, in banking system, you find the patterns of the transaction that are possibly fraudulent or something, and based on some approach like neural network or other things, you just classify some transaction that, okay, it can be fraud or not, right? But in their system, they didn't have any fraud, so we didn't have any patterns of fraud in their system, and I had to come up with a new approach for their data set. Anyway, I analyzed their data set using different approach with the new approach, and I solved the problem. I went to manager and I told him that I have a good news and a bad news. The good news is that I found the patterns of the fraud and I know that what's going on there. The bad news is that it's not your client who are doing the fraud. These are your representatives in different cities who are doing that, right? So my point is that kind of existing approach like recommender systems or classification or clustering that you can use for solving a real world problem. Sometimes you have to combine many things in data science and create a new things for actually solving a problem. So there is another new field also which is emerging recently, and it has been driven from data science, which is called data journalism. Democratizing data, it's a new field actually. Let's say something happens in some places in the world. For example, we have an earthquake in Indonesia, for example, right? And what usually reporters do, they just write some line of codes, report what's going on about this disaster, and I believe they usually go to Google, search for that disaster, and just write at the end about the previous or historical or same situation that exists in Indonesia or other countries as well, right? But new field of data journalism, actually I don't usually read after 4 or 5 lines of the news. But new data journalism field can connect to some kind of data sets, the data sets that are open source. They can analyze their data, and instead of writing many actually textual reports or news, they just give you a chart, a pie chart, I don't know, a trend of the earthquake or whatever. And it would be much interested to just follow up, to just take a look, right? Instead of reading the whole line. So it's a story about data journalism. And other than that, there is a demand and supply in data science, right? For example, McKinsey has reported that we need 200,000 data scientists in 2080 in USA. So it's huge. There is a huge actual demand for data scientists. Or Glassdoor, most of you maybe knows Glassdoor, is one of the best job search engines in the world. In January 2016 has released a report about the best jobs that everyone has to pursue. And data scientist is in top rank in terms of the salary, in terms of the opening opportunities, and other things. So it's really high demand for this one. And I'm sure that many of you have heard that data scientist is the sexiest job in 21st century. I hope you don't see me as sexy, but it is really a good job. And it's really exciting job because you analyze your data and you extract something from your data in 2 or 3 sentences. You can tell a story about a very, very big data like 1 terabyte or 2 terabyte. So it's really a rewarding job, but it has some problems. Exactly same as the models that always try to be sexy, right, and keep themselves very fit. You also have to keep learning, always keep learning, and sometimes there are many inconsistencies in the data sets. You have to come up with the new algorithms, and it's not really easy. I should use that one?
Yes, sir. We will.
I cannot connect this one. Is something good? Okay, so it's a story about data science, and what we are doing in IBM. IBM has committed to educate 1 million data scientists, right? Last year, IBM has announced a major commitment to advance Apache Spark, calling it potentially the most significant open source project for the next decade. So we, in our team in IBM, we thought that how we can help people to just educate them. And we found that there are 2 problems. The first problem is a skill, and the second problem is tools, right? And to overcome these 2 problems, for skills we came up with Big Data University and some meetups, and for tools we came up with Data Scientist Workbench. So let me just explain a bit what is Big Data University. I think most of you know about Coursera, right? So Big Data University also is a MOOC like Coursera, but our focus is only on big data and data science. So all of the courses that we have in our websites are about big data and data science, about Hadoop, Spark, R, analytics, Scala, Python, and so on. So if you go to this website, you can see many learning paths, right? You can start, for example, learning path with Scala. It's start with introduction to Scala, then it goes to data analysis with Scala, after that visualization with Scala, machine learning with Scala, and finally Spark and Scala. So it's a complete learning path that starts with the beginner level and goes to advanced. And one of the good things about the Scala is, I think 1 or 2 of our courses has been developed by the actually person that has created the Scala. So what is this Big Data University? The address is bigdatauniversity.com. It's a community initiative led by IBM. The good thing is that you can take courses at your pace and your place. And all of our courses are online courses about data. Most of the courses have been developed by industry experts, not all by IBMers, but some of them are being developed by IBMers. All of the courses are free. The whole site are free. You don't have to pay anything for the courses, to take the courses, and nothing. And you get the certificate of completion and badge. If you complete a course, you get the certificate, and if you complete a pad, you get some IBM badges. The address is bigdatauniversity.com. You can go and take some courses there. We have a rule of thumb in Big Data University. We tell that we have rule of 5-5-5. It means each course has maximum 5 lessons. Each lesson has maximum 5 videos, and the videos are not more than 5 minutes. So usually the courses are very short. They are not lengthy courses. And we believe that if the course is very short, the chance that students finish it is much higher than very lengthy courses. And each lesson has a hands-on lab using VMware, Docker, or Cloud, or Data Scientist Workbench. Each course has a multiple choice of 20 tests, so you can easily pass each course. And as I told you, usually they are short, not 4 hours, maybe 5 or 6 hours, you can finish the whole course. And if you want to find the course, you can easily go to Google and search, for example, Big Data University Spark. You can find, for example, Spark Fundamental 1, Spark Fundamental 2, and you can take that courses and use it. So we have bigdatauniversity.com. In English, we have in Portuguese, in Czech, we're going to start in French as well. To support our Big Data University, we have some meetups just to support each of these courses, right? For example, we have Toronto Big Data University, the first meetup that we have started, and we have now more than 4,000 members. From the January, we have started, January of each year, we start a series of courses. We start with R, Python, and Scala, then we go for data analysis with R, Python, and we go until the machine learning. We have this meetup in Vancouver, in Washington DC, in Montreal, Ottawa, Tokyo, Chicago. Hopefully we will start in Mumbai and Bangalore as well. And by 2 weeks we will start in Shanghai, another meetup for Big Data University as well. So the good thing is, always we have live streaming for our meetups. So if you want, you can go to bigdatauniversity.com/events, and you can see all of the previous recorded videos for our courses. All of the materials also are there. You can download the materials. Or for the future meetups, for example, we have another meetups in 2 days. If I'm not mistaken, Big Data with Hadoop. You can join and use the meetups in Toronto as well. And other than the skills, we have tools as well. And what tools is the best tool for data scientists? Which language usually data scientists use? R. Python, R, or Scala? Raise your hand if you say R. Okay, Python? Okay, since that Python is most popular. Scala? Okay, good. So, before I talk about tools, I want to tell you another story about data science, right? 3 or 4 years ago, I was supposed to predict Forex market time series. It was a simple project. Many people, usually master or bachelor, try to do some kind of prediction of time series, right? It's very simple. Usually, for example, here we have a time series of data for Forex market. It has started when market is open at 10 a.m. and it's finished at, 5 p.m. So let's say we have some data from 10 a.m. to 4 p.m. and I want to predict the next 1 hour. So, same as other project, I started researching about existing approach, existing software. And I found most of the approaches are some kind of technical approach that use machine learning and artificial intelligence, like neural network or moving average to predict the future. And these approaches are usually based on this principle that there are some kind of patterns in time series, and if you can recognize these patterns, you can predict the future, right? It's same as predicting temperature, predicting, many other kind of time series. But I didn't want to use this approach, this technical approach, because it's very contextual and it's subjective to the domain that we are solving. For example, if we are working on a stock market of a country, the approach is very different and the result is very different from another stock market in Europe or US. So I wanted to use another approach, which is actually a fundamental approach. And in this approach, there is one principle that movement of the market is based on some kind of outsourced data. For example, a war happened in Syria, it affects on the price of the oil, and it also affects on the stock market or forex. Or let's say that we have a demonstration in Hong Kong, this one will indirectly affect on the stock market. So there are some events outside of this pure forex market that are reflecting this time series data. I wanted to use this outsourced fundamental data. And what's the best source for me? I made a decision to use news. So I could collect some news from google.com, news.google.com, and I access this news along with my time series, right? For example, is all of the news that has been released in this day, during one day. So the next step was to just find a relationship between this news and the movement of my market. So I sliced my data in, for example, 1.5 or 2 hours of windows or 2 hours chunks, and I calculated the movement of my market. It's very easy to calculate the movement, right? It's going down, it's going up, down, up, and I wanted to predict the future, the last 2 hours. And at the same time, I chunked my news as well. And I found some keywords which are very significant in this chunk, the second chunk, the third chunk. It's very easy to find this kind of keywords, right? You can easily use natural language processing to find the keywords that are most frequent, or I don't know. For any reason, that keywords are most important. So it was very easy if I could find some kind of relation between these keywords and the movement of my market. If a new news comes up, I could predict the future of my market or my movement of my market, right? So I had a very clean data set. The data set was chunk number from to the keywords that I had and movement of my market, whether it's going up and down. So simply just in the next level, I use a word vector to calculate the numerical values of my keywords. I could use, for example, TF-IDF or word vector or other approach to just convert the textual columns to numerical values. And I could make a classification algorithm, simply like naive ways, like SVM, I don't know, decision tree, and other classification approaches to make a model, to train my model, and use that model to predict the future, right? Does it make sense? Yeah? So I converted the project to a simple data set, and I've started my work. So I had a methodology for my data science, right? And this methodology is the methodology that you can use for running a project in data science, that usually start with business understanding, finding the analytic approach. For example, I know that I want to predict something, data requirement, data collection, to just collect my data understanding, exploration, cleaning, pre-processing, modeling, and finally evaluation. So it was the methodology of data science that I wanted to follow. So I started implementation. So all of them were designed. Now it was time to implement this project. And my estimation for that project was around 2 or 3 weeks with all of the troubleshooting and all of the problems that usually comes in the implementation. So the way that I started implementation was scraping news with Python, and then virtualization, news mining with Python NLTK, which is a package that is used usually for natural language processing, is very popular. Cleaning, exploration, merging, forex time series using R, and classification with Weka Rapid Miner, which that time Weka was very popular in 4 or 5 years ago. So I implemented the project, and it was very fast. And I ran it, and what was the result? I failed. My result wasn't good. My accuracy was very low. Why? Can you guess?
Very less data.
Yes, exactly. My data wasn't enough. The news that I've collected wasn't more than 50 megabytes. So I started collecting more data from Reuters, from BBC, from CNN, and also from Twitter, right? Because Twitter also is somehow a spatial temporal data. It has geopolitical and also temporal data. So I could align that data also with my news data. So I've collected a lot of data from everywhere. And again, I started implementing my project using big data, and I use also word vector to a bit bring up my accuracy, and I implemented everything with Python. And what was the result? Good or bad? Still, it's using only one machine. So I was lucky that time. I had many machines in the academia that I was working. So I installed Hadoop on many computers, many nodes. And because I was Windows user, it wasn't easy. That time wasn't many documents about the Hadoop. So I installed many virtual machines, installed Ubuntu on all of them, learning, configuration of them, and networking. And finally, I make Hadoop running, and I implemented again my project in Hadoop and run it. And what was the result? Failed again. Still, my accuracy wasn't that good. Still, my accuracy was low. The speed was good, but the accuracy wasn't that good. So I went back to my project, and I looked at my project again. I found that there are two problems here. The first problem is that when an event happens, for example, when demonstration happens, or a war happens, or I don't know, there is an election in USA or something, usually the duration of that news or the time that affects on the market are not fixed slice windows, right? Sometimes it takes 2 hours, sometimes it takes 3 days. So I couldn't use exactly fixed chunks of the data for prediction. It should be somehow dynamic based on the event that is happening. So I should do the event detection based on the news. And for event detection, I should use clustering algorithm, right? Which is somehow unsupervised approach to find the best and similar news to each other. Another problem was that when news released, it takes, let's say, 30 minutes to affect the market. So always there is a gap, or there is a, what they call it, a span between the releasing of the news and affecting on the market. But I didn't know what's the best time for that one. I should run it many times to find the best or optimized value for that one. So what I did, I used the clustering algorithm, changing my problem, and to find the best approach. But you cannot run clustering on Hadoop, right? Why? You have any idea? Clustering algorithm is an iterative approach, and Hadoop is not working well with iterative approach like clustering. So I had to install Mahout on top of Hadoop, and I used Mahout to run the k-means. Also, there was a problem. K-means code was embedded in Mahout, and I couldn't easily change the code. So anyway, I ran this algorithm using Mahout, using k-means, and I succeeded in my project. Right? But the project took me around 5 or 6 months instead of 3 or 4 weeks. And it wasn't good. So I was very happy because I learned a lot in this project. And one day in an actually casual lunch with some of my friends and colleagues, I was telling the story about how I started the project, how I installed the Hadoop, and so on. And one of my colleagues told me, why haven't used, for example, Spark? Spark is very cool, it's very fast and something. But the problem was, I was really frustrated. I couldn't change my technology again. I have created my environment, all of my virtual machines, right? So for 2 or 3 years, every company that I went, I took all of this virtual machine on a hard disk, and I installed all of this virtual machine, and I ran my processing and data science things that I had, right? Because it was very hard for me that just jump to another thing, learn new things. So one day I was thinking about this project. I thought that I know about the machine learning algorithms. I know how the problem is going to be solved, and my approach was almost correct, right? And it only took me 20% of my energy. And 80% of my energy went just to install configuration, learning new things, re-implementation with Python, with Java, just configuration, installing all of this package, and so on. So I thought that, am I really a data scientist? No offense, or I'm a data engineer, right? Because data scientist is supposed just to apply his knowledge, the algorithm that he knows on real world problem. He's not supposed to do configuration, integration of data, extracting data, and so on. So it's actually one of the differences between data engineering and data scientists, right? Data engineers are usually like plumbers. Just bring some data and clean it and integrate the data for us and make this ready for us, and we just run our algorithm to just take some insight from that. So usually in this area we have data analysts, which are very close to BA, and somehow they are junior data scientists. We have, okay, Pawan I think told me that you can tell about the salary. Their salary is usually in US around 65,000, 70,000. We have data engineers that usually do some kind of plumbing. Their salary is between 65, 70 to 100. Okay, they know good things about the Hadoop. They can easily handle different data sets, databases, big data. And we have data scientists, senior data scientists, that their salary start from 110 up to 130, 40 by average. So my salary is not that much, but it's the difference between these three. And if you want to be in data science, or you are interested in this field, just be careful, don't fall in trap of data engineers, right? Because data engineers usually are doing manipulating data and so on. So anyway, I was one day in downtown Toronto and I went to a meetup. I saw a guy brought up a website. Okay, he started writing Python code inside that website and then runs a classification to classify something. After that, he sent that code for running on Spark, and then he closed it and told everyone that you can go and continue it at home. And I thought that is wonderful. You don't have to install anything on your computer. You open a browser, you have a place that you can start writing your code, and it's all on the cloud. And you have also a Spark, and it's really good. And that time I wasn't in IBM yet, okay? But later I found that it's data scientist Workbench. It's actually a website on the clouds. It's open source, it's fully free, and it will be free forever. It has a Spark and many open source tools. So what it has my data that you can put all of your data set there. It has 100 gigabyte data for free. So you have a space of 100 gigabyte. It has OpenRefine. Are you familiar with OpenRefine? Raise your hand. You know OpenRefine. Yeah, OpenRefine is an open source project by Google. It was open source project by Google. You can use it for cleaning data, for reprocessing data, and especially it's very good for with textual data. You have IPython notebook, Jupyter notebooks. How many of you are familiar with Jupyter notebooks? Okay, many of you. So it has Jupyter notebook and IPython notebook that you can run Scala, R, and Python code, and already it has connected to a Spark machine. It has RStudio. Okay, you don't have to install RStudio on your machine. It has RStudio on the cloud, so you can use RStudio to run R, and it's connected to a Spark. It has Zeppelin of the Apache. It's still in incubation. It's very cool because you can run SQL on top of data frames in a Spark, you know better than me. and you can use Zeppelin as well in data scientist Workbench. So, can we have a break for a few minutes?
Yeah.
So we can go for break, then we come back, I will show you some demos on data scientist Workbench and the work that I've done with data scientist Workbench. 10 minutes, 15 minutes?
So let's take a 15-minute break. There's refreshments at the back, and we will assemble at around 11:15.
Still power.
Go back to the slide. Go back. This one.
Right button on top. No. Quick
Demos on data scientist Workbench and show you how you can use data scientist Workbench to run your code. Just a few questions that some of your friends had asked. So, one of your friends asked me that data scientist Workbench is a bunch of open source applications like RStudio, like Jupyter Notebook, like Zeppelin, and we are using CPU, right? We are provisioning some CPU and also the space, 100 gigabyte space. Is it that part also free? Yes, that part also is free. So you can upload your data up to 100 gigabyte and you can use the CPU. I don't know how many cores each one has, but I think it's powerful as a good laptop. Sometimes I run something on my laptop and it's not good enough, so I run a data scientist Workbench. And it has, I think, 8 gigabyte RAM as well. So it's like a good laptop that you have to run such a program. The Spark that already installs in data scientist Workbench is a local Spark with, which is using, I don't know, 4 cores or 8 cores. So it's exactly the same as what you have on your laptops or computer. The good thing is, as soon as a new version of Spark comes, we upgrade the Spark, we upgrade R, Python, all of the packages that exist and usually people are using, right? So if there is a specific package that you want to use and doesn't exist in data scientist Workbench, you can install it. Pip install, blah, 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 right? Some packages need some kind of privilege. You cannot install, but there is a place, user voice. You can send your request and in one day we will install for you. Actually, when we install for you, we install for everyone. And yeah, all of the packages that exist in R and Python will be upgraded. For example, if you are using scikit-learn, as soon as a new version of scikit-learn comes, we test it. If it's good, we will upgrade it for you. Okay? How many of you have registered? I know that Power has sent a message yesterday that register for data scientist Workbench. Have you registered for that? Yeah, a few of you. Just a hint. The first time that you register for data scientist Workbench takes up to 30 minutes to provision this Workbench for you, right? Because it's a system on the cloud and it should bounce out. So, but after the first time, it will be very fast and you can easily use it. But there is one point. If you don't use data scientist Workbench for, I don't know, 2 or 3 weeks, you don't like it at all, we will hibernate it because it's expensive for us, right? It's not that you lose your data, it's not that you lose your account, we just hibernated that. And next time that you open it, you should wake it up, right? And again, it takes around 10 or 20 minutes to wake it up. So if you use every day or wake up, it wouldn't be go to the hibernate mode, otherwise it will happen. So before I explain about data scientist Workbench, I just wanted to go to Big Data University, just show you how it works. So the address is bigdatauniversity.com, and you can easily log in. So here you can see the list of courses and list of learning paths. For example, I can go to learning paths. And here are the list of learning paths. For example, click on Scala. You can see that there are now 3 courses finishing Scala, Introduction to Scala, Spark Overview for Scala Analysis, and Scala for Data Science. You can easily click on that and take the course. It's very simple, and you can take each of these courses, and at the end you get some kind of, I don't know, certificate or badge. There are many courses. I'm not going to explain about the learning paths. I think it's very easy to understand the whole idea. Okay, let's go to Data Scientist Workbench. The address is datascientistworkbench.com. So, if it's your first time, you have to register here. If you have already registered, you can easily log in. So it's an environment of Data Scientist Workbench. As you can see here, we have My Data, OpenRefine, Jupyter Notebook, Zeppelin Notebook, and RStudio. Okay, I will start with Jupyter Notebook because most of you already have worked with Jupyter Notebooks. So as soon as you open Jupyter Notebooks, you can see a list of my notebooks. Most probably when you open a Jupyter Notebook, you don't see anything, just you see, for example, a recent notebook and recent data. Right? So, if you want to create a notebook, you come here, you have option of Python 2, Scala 2, R, and Python 3. So let me open a Python 2. So you can start writing your code here easily, right? A equals 2 plus 2. You can click here and run it. And A, you can see your result. You can write all of your code here, and as soon as you finish, you can stop it and close the notebook. So I had prepared an intro to Spark for you, but most of you are already a Spark developer. You are familiar with this. I'm not going through the codes. I just want to show you that how it works. So I start running it. SC, it shows the context of SC. The version of my SC is the newest version, 1.6. If I'm not mistaken, it's the newest. So here we have an array. We can parallelize our array and run each cell by Shift Enter, Control Enter, or just clicking on this run. Each cell has somehow a designation, so when it's running, it shows some kind of stars. As soon as the run is finished, you can see the results, right? So let me open another workbench here, for example. Here I have K-means Spark weather. I prepared these notebooks for weather hackathon in San Francisco. So I think that it will be interesting if you look at the codes here. My temperature. So for example, if I have latitude and longitude of a place, I can use this model to predict that whether it goes to other. Because he is from Pakistan, he has found that most of this kind of bombing and terrors happens on Fridays. Why?
Yeah.
Because there are some kind of ceremonies or praying where and good target for this kind of terrors, right? So it's why I'm saying that other than the technique, you should have some kind of domain knowledge to do some kind of data science problems. It's about the Pakistan. The same guys has analyzed the data set for scoring professors in universities in Canada have found that usually professors who are very good looking as better scores. And so we have published a paper that appearance or good looking pay more, right? So the students give better score for these guys. Doesn't matter if they are good professors or not. Right? Any question? Yeah.
As you said, used to work on old technologies, means old days, that you had to do more on manually. Right. Now, means on those days you more work on history data, right? Which was available, and during that time I don't think so. I'm not sure that live data was useful to create model. Means current data, any live feed or something.
Right.
Because there was no technology to get live stream. So with big data and Spark, now we have streaming. So you can get streaming, right? So you can get live data like weather, as you have given example for flight delay. Suppose you have created one model, right, in linear regression. One model is based on your data, which is based on history, like 2007. Now, this for example, I am not exactly correlating that, but now we have one more model which is correlated to weather and which is live, right? So you are creating one more final model out of these two models. So this is like something new we are seeing with this new technology. So how accurate it is compared to that old days? One model with live data, correlate and merge with your history data.
Yeah, see, actually I forgot, I wanted to show you a streaming demo as well. If you have time later, I can show. See, first of all, what I did also was two models, right? The first model was classification model to find what's the movement of the actually the stock market, forex market. And I had used another model on top of that for optimization. I used the clustering to find the events. So it was the combination of two things, right? At the same time, it was combination of two different approaches, mathematical approach and text mining, right? But yes, today we have many outsourced data sets that we have to add to our raw data, right? For example, we are analyzing transportation data. We definitely should add weather data to see whether weather will affect on transportation delay or not. For example, same thing, in the flight, I use the weather data, right? And unfortunately, in the future, people who has the power is with the people who has this kind of outsourced data sets. If you have weather data, you have Twitter data.
It's not live, this is something new we are seeing.
Yeah, if you have weather data, you have Twitter data, you are fortunate. You can analyze very fast. And on top of that, if you have some kind of models prepared for you, right? For example, I have a model that I can easily find, for example, rare cases in weather. Can give me an alarm, right? For example, I ran a streaming approach. I used the Spark streaming to read Twitter data, right, online as a streaming. I go through all of this streaming data. I cluster them to see what people in different areas of the world or the country are talking about, right? If I have created already that model, I have data set, Twitter data set, right? I have prepared that model. This model is like a weapon for me. If I'm analyzing something, definitely I will use that model as my input to my second model, right? So yeah, if you have more data other than raw data, you have power. If you have model based on your outsourced data, you have a good power.
So this is like more accurate compared to the old days results?
More accurate, definitely. I can say that, yeah, it's more accurate because you have outsourced data.
But it is also about the context, right?
You think it's something?
It's also about the context. The more different sources gives you more context about what the problem is. maybe I don't know, weather changes. Weather changes. People started talking about weather changes in Bangalore because of less greenery after 1990, after a software boom has happened. So now you can have certain other things that you can correlate why the model or the data change for a period of time.
Yeah.
That's I think that's one of the more important ones.
Definitely, you add more context, like weather, like public opinions, like I don't know, many other outsourced data. It will get more complicated, and definitely it's subjective to what domain you are working on, right? Yeah.
So the more the different sources of the data, your model becomes more complete.
Complete or complex?
Complete and complex.
Yes, both. Complete and complex.
So the only thing I would like to add is you could also be careful about adding more noise to this, right? So sometimes, yes, you have lots of different data sources that you can keep on adding and make it complex, but then it could also be noise, and then you could probably not decipher enough from that particular noise as well. So you've got to be careful that you've got to make sure that there's a strong correlation between all the data.
Very true. Even Netflix ran the recommendation engine contest for 10 years. Who will improve? So the final winner was a model that had around 108 different algorithms, and they ditched it because that was way too complex, and they don't need all that. They did the recommendation based on people collaborative recommendations. So, and that was more easy and more effective for them eventually.
Actually, in fact, adding more data by more attributes will add to more noise. So then you have to use things like dimensionality.
Correct.
So adding more might not necessarily
mean always the correct thing. But you will know only if it is noise or not only after adding and figuring out whether it is really helping you or not helping you. Then you can do the dimensionality reduction. I would still say you need to add it, see if it makes any sense. If it is adding noise, then reduce it.
Correct. You need to run the correlation, right? So you
Yes.
got to make sure that the correlation between two sets of data is very strong. If the correlation is weak, then you got to drop it.
Correct.
Right? So that's how
Correct.
Again, it's like cleaning your data and refining your data, which makes a big difference here.
Yeah.
So which you can reduce noise here.
Correct.
So this is all essentially feature engineering, right?
Sorry?
Feature engineering.
Future engineering.
Feature selection, feature, yeah. See, always the problem is, I always see one problem one level higher than that, right? You usually can understand that if you are solving, for example, problem of whether does development has effect or not. Then goes to the lower level that, okay, we have this field and they are correlated or not. You know what I mean? So usually the problem is higher level. For example, the weather here is hot, right? What are other resources that is happening? You can easily understand. It doesn't need that you collect a lot of data, after that put all together, then run I don't know, an ANOVA test to find the correlation between all of these and say that, okay, these are important. So if you have some kind of raw data, think further about that. My suggestion is, think further about that. Think that what else can help to enrich your data? Is it whether it is the temporal data, it is the vicinity, it is the characteristics of the people who are living over there or what? And then collect them and then run some kind of correlation or other approach to find whether are correlated or not. Sometimes making the problem very complex, it doesn't help really. And it's a very cool thing, right? You can easily pass all of the notebooks to everyone. So that's it. If you have a question, I'm here to answer all your questions. Yes, I will share the examples are all in the data scientist workbench. If you go to data scientist workbench, not all of them, most of them. Some of them I cannot share because it has some data from, it has some confidential data, but the data sets that I show you for Spark k-means I can share with you, for the flights I can share with you, but for the oceanary data I cannot share with you, but other things I can share you. And for the PowerPoint, hopefully by tomorrow I will put somewhere in box and send the link on meetup.com. You can use it.
So let's open it for a quick.
Sorry, can you speak up?
During the starting of the presentation, you said that you had to solve the insurance problem.
Right,
You said that you have to go through a new approach.
right.
So can you explain the technical challenges you faced with the old approach and how you will
Okay, let me repeat your question to make sure that I understood your question correctly. You are asking that in first of my presentation I explained that I had a project in insurance company. I used a technical approach that wasn't normal approach in comparison with other approach, right?
technical challenges you faced and how you were able to
What were the technical challenges you faced and
how you were able to solve them?
Okay. I explained about technical problem. Technical problem was for fraud detection, you have usually two approaches, right? The first approach is finding you have some patterns of the fraudulent, right? For example, in banking system, there are some kind of patterns. If you buy something with your credit card here and 10 minutes later someone else in USA buys something with your credit card number, it's a pattern, right? And if we have such a pattern, we can use normal classifiers or neural network like classification with decision tree and other things to detect such a fraud. It's the first approach for fraud detection, usually. The second approach is outlier detection, right? For example, most of the people in insurance that are causing some kind of damage or injury are in age, for example, 25 to 40. If you have a case that it's 65, it's outlier, right? And you have to catch that. So it's the second approach. The problem that I had was I couldn't use none of them, right? Using clustering, I couldn't reach to any sensible answer because it has many fields. I couldn't use that one. And using classification approach also, I didn't have any patterns. I didn't have any fraud in my system to just learn my model, right? So I somehow had to do something new. And the first thing that I did was I searched I ran a clustering algorithm, but not to find the outliers, just to find some kind of very similar cases, right? And for similarity, I put the address, right? And I found that there are some cases that they're living almost in the same address with a bit difference, and they had 2 or 3 claims for some kind of injuries in 2 months. I thought that, okay, this family should be really unfortunate, right? Because they have, for example, 2 dies and 1 injury in 1 month. But it wasn't like that, actually. The first time was correct, the second and third time claim, representatives was doing that claim for them. You know what I mean? So for this kind of cases, it was actually similarity based on the text, right? Similarity based on the addresses, right? My point wasn't that to find such a thing. My point was that to find that which area or which regions of that cities or that country usually this kind of claims happen. But by chance I found something else. So it's why I'm saying that you cannot use always normal approach or common approach or the 10 most popular approaches of the data mining and machine learning to solve all of the problems. One of your friends asked me a question that it was very interesting. Actually, there is something very interesting about data science. It used to be you should have some kind of PhD to be a data scientist, right? Because most of the problems were like this. But today you shouldn't have a PhD. You shouldn't have to have a PhD, right? Because the algorithms are there, the solution for different problems are there. If you have a master, bachelor, you know some codings, and you are familiar with actually domain knowledge or domain you are working, you can easily use the normal approach to solve the problem. For example, I just give you an example of domain knowledge, right? Okay, you know that, for example, many bombing or terror happens in Pakistan, right? If someone gives me that data set and I just start working on that, maybe I cannot find anything interesting there. Why? Because I don't have any domain knowledge about the culture there, right? But some guys from Pakistan has analyzed that data, a professor from right, I have delay or not. For example, if months is 6, it sounds that I don't have any delay, but if I go to months 9, still I don't have. Day of weeks, for example, the first days are usually supposed to have a delay, so I put 3. And for example, 7 o'clock or 8 o'clock, it's supposed to change. Oh, let me check. I had one example, yes. Month 2, day 3, February, which is very cold. So I put 1, 2, that still doesn't have flight, day 3, because the flights that has delay in comparison with the flights that don't have delay are not that much. So CLE, 1, 2, day 3,
Or 80.
80. Sorry?
Greenland has probably lesser traffic, take another airport.
I think I've tested slowly and it has. Let me just refresh this one. It's very hard to find a flight that has delay because it's very rare. And now, which is still working. So it's why I put a sample case that it has delay. And it makes sense because 6 hours is peak hour for the flights for the airport. Third day is actually Monday that some of the flights have delay, and the month is 2.
This is delayed mostly because of the takeoff in JFK, or it could also be at the destination?
From JFK, it can be because of the destination, right? If you know any other, but the problem is still running. Yeah, let me try one more time. So I put CLE, and for months I put 2, and for day of week also I put, for example, 3, and change hour to 80 or something. Okay, I don't know, for any reason it doesn't work now. So it's the way that actually you can play with the widget, and sometimes I've seen that it says that, okay, your flight has delay. So it's a demo using a 600 megabyte data, right, only for 7 million. What about if we have a very, very big data? For example, I don't know, we have 50 million data sets, right? So I have exactly another notebook is doing the same thing, but my data set is very big. It's for many years of the flights, from I think 1998 until 2016. So it's big data. I put this data set somewhere on the cloud on, if I'm not mistaken, it's on HDFS system. I want to load this one and run it. If I want to run same as this way, using notebook, it takes forever, right? So we have another option in Data Scientist Workbench. This one is the notebook with big data actually. All right, let's stop these things. This is the same data set with all of the codes, but instead of running one by one, each cell by each cell, I just go here and click on this arrow key, and I select submit to a Spark cluster. If you come here to the size of data set, see it's on HDFS, and the data set is from 2001 to 2008. right? And the data set is very big. It's around 5 gigabytes. So what I do, I just click on this one and submit to a Spark cluster. What's happening here, data scientist Workbench take all of the Python codes, it put all together, it creates a Python file and sends to the cluster. It's not local cluster anymore, it's on the cloud and it's a big cluster and run that one for you. So I click on submit to a Spark cluster. It creates a new notebook for me. Actually, it's generating the Python code. And it asks me that I put the address of the notebook that I want here, right? And will submit my notebook to this cluster. So I easily goes and put the address of my notebooks here. I can put insert pad like this, and I run this specific cell. So see, it's connect to the Spark and submit the job to the Spark cluster. And it's stop running my cluster. So you have two options. First, use a notebook, local Spark is free, or you can use the submit to cluster. If your data set is huge, you can send for a cluster and it can be run. So, as while it's running, I want to show you something else. As I told you, there is RStudio also is data scientist Workbench. I am going to open RStudio here to just show you how RStudio is working. See, it's exactly the same as RStudio that you install on your laptops. So you can start writing your code here. For example, A equals 2. And you can see the result, the variables. You can load your files, R projects, and so on. And you can easily use RStudio. Are you familiar with RShiny? Are you work with RShiny? Yeah. Sometimes you create an R project, right? And you have a data set, you do some analysis. You want to publish it, right? You create a chart and you want to publish it. You want to show your manager or your friends. You want to share it. And you don't want to share your data set. You don't want to share your code. So you want to create an application, right? So you can use the Shiny R. And this, I don't know, is RShiny or Shiny R? RShiny. This RShiny is already installed for you. You can run this one and you can create an app and share with others. I don't know, we have time to demo it or not.
How long will it take?
Okay, instead of, I just ran it if it's, because it takes time to run an application, I just run it. If it comes up, I will show you. Yeah, it's running. See, there is a part of code that I've written in R. It's a very simple R code. It has two parts, server and UI. UI is the part that you can show everyone. And here you have the application, right? And you don't have any code. So you can easily publish this application on web or show your manager or everyone. It's not like notebook that there are many codes there. So for example, here is one area of Canada and we have some stations there. Here we are showing the temperature of this station, salinity of temperature. It's actually related to a station in the ocean. So you can see many information about them. You can filter your data. You can select, for example, instead of this year, I want to have data of, for example, 1939 until some other days. You can easily handle your data. For example, I want to have many data points, more than 41 data points. And you can interactively work with your application. Let's go back to the previous submit to Spark. I hope that is finished. Yes, it has finished. And it's your result. If you look at the accuracy here, the accuracy is 79%, right? If I used a small data set for 2007, my accuracy was only 72%. But here I've used a big data set and my accuracy is 79%. Last point is that you can easily share notebooks with others. So here you have an option that you can share a notebook with others. You can share a notebook on Facebook, on Twitter, on Gist, or you can create a link, and I can share this link with you. And as soon as I share with you, you can open it in Data Scientist Workbench. So for example, I can copy these links, go to Meetup page, and for example, I put it here.
Does it require that the other user also
Yes.
have to?
If you have registered for Data Scientist Workbench, as soon as you click on this link, it will be opened in your Data Scientist